Cool. So hi everyone, welcome for thank you for joining us today. I'm Julia Furst Morgado. I'm a principal developer relations engineer at Dash Zero. I'm also an OpenTelemetry community manager. And today I have with me two of my colleagues, Kasper and Mauricio. They both presented at KubeCon EU in Amsterdam. What, a month ago? I think it's over a month,
Yeah,
right?
it's over
Two
a
months
month
ago?
now. Yeah, nah,
Yeah,
well, yeah, a long time.
yeah. Time
It feels
flies.
like forever.
And their talk was about building agentic and event-driven systems and making them actually observable without making life harder for developers. So
Mhm.
today we're here to go a bit deeper, to talk about the decisions they made, what they had to fix, where the community is going, after this. And if you have any questions throughout this webinar, this conversation, feel free to drop them in the chat or in the Q&A. I'll try to take a look at both, and we'll get to them at the end. And yeah, let's start with maybe some introductions. Kasper, Mauricio, I'm really happy to have you here. Maybe let's start with Kasper. Who are you?
Sure,
What do you do? And what are you working on right now?
sure. Yeah, first of all, thank you for having me, Julia. It's awesome to be here. I just recently changed role into Director of Product Marketing and Developer Relations, coming from basically a principal developer relations role as well at Dasiro. But I have also spent 8 years as a platform engineer, SRE. In the early days, it was called DevOps engineer. So building, Kubernetes infrastructure, running all kinds of different systems, building internal developer platforms, all of that. And then also been part of the cloud native community for quite a while. I've been an ambassador since 18, I think, something like that, as the NCM ambassador. Been, organizing meetups in Denmark, also organizing the not KCD anymore. We did a KCD the first 2 years, but now it's called Cloud Native Denmark, and which will take place in November as well. So if you are around the area, stop by in November on 19th and 20th. And yeah, what else? Yeah, Golden Cubes or not, try to challenge
Yeah.
myself. So I took all the certifications there as well. And now, yeah, I'm trying to figure out what this product marketing and management role is actually all about, but still doing some of this. So I think that's the short version. And
Yeah.
yeah, maybe over to you, Mauricio.
Yeah. That's really cool. That's quite a lot of things, right? And for me, it's kind of interesting. So I joined Dash Zero right after KubeCon, right? So you will see even in the presentation that before I was working with another CNCF project called Dapr, where I'm still a maintainer there of like one of the SDKs and the project. And we basically met with Casper like a year ago, almost a year ago, and we started collaborating in the open. And with all the changes that are happening in the industry, yeah, I think that observability for me meant that, things are changing, things are becoming more complex, and joining Dash Zero was like a rational thing to do for me at this stage in my career. But yeah, I've been involved with the cloud native community for a long time now as well, since 2016 to 2017 or something like that. And I contributed to a bunch of open source projects, and most of the times that's kind of like what I do is like I like contributing, I like pushing projects forward, and that's why I joined like as an ecosystem engineer here at Dash Zero. And you will see me collaborating a lot out there in the open with other projects, with other companies, and one of the reasons why we're here is because of those collaborations, I think. So I'm super happy to be here, and you will see me doing a lot of this, I think, this year. Yeah.
Well, thank you. As you can see, I have two superstars with me. Really excited for this webinar. Now, before we start, I want to ask you two something. I went and pulled the abstract that you submitted for KubeCon. It talks about the Dapr workflows, the OpenTelemetry operator, no-touch instrumentation across async boundaries. Really focus on that. No mention of agents, AI, nothing like that. And then I watched the talk. I had to watch the recording because, KubeCon is crazy. It's hard to be able to watch all the talks there. And it's a pizza store with four agents talking to each other over protocols that were barely a few months old. So what exactly happened between submitting that abstract and walking on stage in Amsterdam?
Well, technologies evolve pretty fast, right? Especially nowadays with all the AI stuff going on, and it just seemed like a good topic to address because I think we already decided back then that the title was Taming Complexity, and then we were just like, okay, there's more complexity now. Let's bring even more complexity into this talk, and then I think Mauricio, you can probably talk a bit more into this, but you went crazy on building and trying out this technology and build a cool demo.
Yeah. Yeah, I think that like the whole point was to show kind of how complex building simple applications is, right? Like just like on the building side. And when we start thinking about like observing this stuff, it becomes like the more complex it is, the more important it becomes to be able to observe it correctly and understand what's going on at all times. No matter if you're troubleshooting, no matter if you're running at scale or if you're actually like doing some development tasks, right? So we looked into the kind of like the ecosystem, the industry, and the new protocols that are popping up, the new frameworks that are popping up to build agentic applications. And we said, okay, let's demonstrate complexity by showing all the new stuff that is coming up really fast. And we need to kind of like accept in a way that more new stuff is coming along the way. But no matter what those things are, we just need to be able to observe and be able to manage all this in a way. So yeah, we kind of changed a little bit the angle of the presentation, but I think that the topics are still the same.
Yeah, and the topics are really fresh. So technologies, new technologies, and talking about AI, which is something we're all talking about nowadays. We have new changes every day. So yeah, I'm excited. I'm going to go ahead and give you to the mic. You can share your screen. I'll go mute myself. And then at the end, I'll take a look at the questions. I have some questions as well, and we'll go through them after. Thank you.
Sounds good. Thank you.
Sounds good. And if you see any questions from the audience at any point, please feel free to stop
Sounds
us.
good.
Right?
Perfect.
I'm not seeing the messages, but like if you see something,
I'll do that.
Bring it up. Yeah. So yeah, so as Julia mentioned, we presented this at KubeCon a month ago. It feels like forever. By that time, as I was working with the Dapr project, and this like demo has some Dapr in it, so we will talk a little bit about that and why is that relevant from the agentic ecosystem. So let's get on with.
Yeah.
We already introduced ourselves.
Yeah, let's just skip that.
Yeah.
So basically, if you like the too long to watch sort of TLDR or whatever we call it, whatever the acronym is that as your applications and infrastructure grow in complexity, you must have the tools to understand what is happening at all times. I think that is really the key thing about this, that you need to understand what your systems are doing. And if we skip to the next slide, then we've sort of come from a world where these architectures have just been evolving and evolving and evolving. We started like in the early days with the monolithic applications, and then back in 2012, 13, 14, around that time, microservices came around and we started to just distribute everything. I think there was some attempts earlier with the service-oriented architectures and stuff like that. And nowadays, at least when we started this, it was the event-driven side and creating doable workflows and all of that. And now we are moving into a world of agent-based. We will see probably even more of this, that we can, in some cases, replace some of the services, maybe with some agents doing other stuff and dealing with even more complex workflows. So yeah, the evolution of architectures is quite interesting. And this is probably just going to scale even more as we go further ahead.
Yeah, and with like with any style of architecture, right? Like new challenges arise, and then like you just need to understand like now how security works, how observability works, how resiliency will work. So we're kind of like interested in those topics, and we will just explore a little bit of that.
Yes. Yeah, so we gave like this talk and sort of the background for the original talk was basically this talk that we gave in Geneva in December last year. So if you want to like watch a talk that is more focused on the async communication side of things and how to observe the doable workflows with Dapr, take a look at this talk on YouTube. It should be there somewhere if you just search for Golden Paths for async workflows. But this one, as mentioned, is more diving into the more agentic AI, MCP tools, skills, whatever we have. I think Mauricio will gonna show you a few things now.
Yeah, 100%. So before we jump into the demo, right? Like when we talk about agents during this presentation, we talk a little bit about more business agents, right? Like we are not talking about coding agents like Cloud Code or Copilot or Codex or anything like that. We're just talking about agents that are designed to solve like business processes, right? So when you design these kind of systems, first of all, you need to understand a little bit about how do you scale them, but also how critical they are, right? Like if they are like end user facing, like front facing, it's just very hard and very critical for these agents to work correctly. If they start doing crazy things and then messing up with your customers, that's not a good thing. But we wanted to focus on this because there are like other presentations and like other patterns that will apply to coding agents that are not covered in this presentation. But we can like recognize that there are like a big overlap between these two worlds. So some of the things that we will cover here as well, they will apply to coding agents as well. So just keep that in mind. We are talking about business agents here. So we will see that in the demo, that it's pretty clear. But before we jump into the demo, as I mentioned before, like in the introduction, it's more like we looked into the industry and we kind of like try to see what people is trying to build nowadays with the new tools that are popping up. And that's why we went into the agentic way of thinking, right? And when you think about agents, of course, that you will have like some sort of like large language model somewhere that you can interact with and then do the reasoning steps. You will have other agents that you can interact with, but protocols like like MCP and skills now, like the skills definitions are becoming more and more popular ways to connect like an LLM to the things that are more closely related to your business, right? So it really depends on the business that you're dealing with, but the tools that you're going to be calling from, like the LLM will be calling to, and the skills that the LLMs are going to use are more contextual to your business domain. And sometimes you will have other agents internally in your context or external agents that you need to interact with. So we will be trying to cover kind of like some of these aspects when building these kind of agentic applications. And of course, we don't have like we don't want to spend too much time discussing about what MCP is, but think about MCP as the protocol that allows us to tell the LLM what are the tools that are available for the LLM to call to do some actions and get some extra data that it needs to perform whatever operation we have designed in our LLM or inside of our agent definition. MCP, the protocol itself, was introduced by Anthropic in November of 2024. So that's like less than 2 years old, right?
Yeah.
But it has been widely adopted, right? Like there is a lot of buzz around the protocol, and there are like a lot of solutions being built around this. Do you want to add something, Kasper?
No, it's just crazy that it's not even 2 years old and it's everywhere now,
Ex-
right? It's crazy.
And it's everywhere. Every company is building their own MCP servers, and MCP on its own, it has a lot of like you know, let's say maturity problems because it's quite new, right? Like it needs to mature in order to be, you know, let's say production ready and being able to be used at scale. So that's one of the sides of the things that we need to explore. The other thing that it's important to mention is the A2A protocol. It's even newer. So this is coming from April 2025, a little bit over than a year ago. Google introduced this protocol to basically define how agents can communicate between each other, right? It's kind of interesting. It's a complement to the model, to the MCP protocol, right? Like it's not a competitor. It has a different purpose. This is more about like intelligent agents sharing information and updating each other about the stuff that they are doing. You can see here like the pillars, right? Like secure collaboration, task management and state management, user experience negotiation, and capability discovery, right? Like that's the core focus of this protocol. And again, it kind of makes sense when you have two intelligent agents that are talking to each other. It's kind of interesting the approach that they took because they took a like enterprise standard approach, right? Like in comparison with MCP, that it seems more like we will like define a basic protocol and then we will start adding capabilities. The A2A protocol basically looked into a more like enterprise kind of like solution already. So secure by default, supporting long running tasks, and then kind of like trying to define the new stuff that for me it's really interesting. For example, like modality agnostic, right? Like accepting that agents, like as we know now, like large language models are dealing with text, but there are other models that will deal with audio and with video, right? So providing the standard protocol for these agents to interact using video, audio, or text, I think that it's super important and it's built into the protocol itself. In the demo, we are not using those because I think that will be super cool. But like, I think that it opens the door to think about like, okay, how do you observe video interactions between agents? I have no idea. that's something that we can discuss in a different
maybe in a talk in the future. We'll see.
100%, 100%. And finally, skills, right? Like this is the newest kid on the block, December 16th of 2025. I don't even know how long that is.
That's 6 months ago, not even 6 months ago, right?
Yeah, and this is a little bit more like insane, but at the same time, it kind of makes sense that this popped up because people started to try to figure out how to add like contextual knowledge into LLMs, and basically a simple way to provide LLMs extra context that it can use to perform different tasks. And the main reason why I'm showing this, the skill spec basically that defines like what's a skill is just an MD file with some optional scripts, with some optional references that can be documents, PDFs, whatever, and some other things that the skill can use to reference, right? And this is where things became a little bit like esoteric, in my opinion. Now we have MDs that define instructions or provide context for the agent, but also it can provide scripts and executable code that the agent can call. And again, that's kind of like also interesting to figure out how this is going to impact in our architectures, right? Kasper, do you want to add something?
Yeah. No. I mean, it's just crazy. My Instagram feed at the moment is just like people trying to like get rid of, different job titles with skills and in all kinds of different categories. It's quite interesting. It's crazy how much momentum this term or this way of defining. It's
Context,
just exploding.
right?
It's crazy. It's very interesting.
Yeah. And the fact that it's like less than 6 months old, and we are all talking about this, and we are all trying to use it in a way, like trying to discover the possibilities that we have around this is super important. So, and I think that this is pretty much why we decided to create this pizza ordering app, right? Just to show all these things in action, because one thing is to talk about them, but the other thing is just to see them live. And by the way, the demo that we are running here, you can run it in your own computer. So we will be sharing some links for that, but you can just run it in your own setup. I am currently running this demo in my laptop with a Kubernetes cluster that is running locally here. So let's jump into the demo. So the demo looks like this, right? So we have two screens, one that represents kind of like whatever the user sees. Imagine this is like WhatsApp or like an application that you can access in your phone. And then what we see here is, let's say, the agent's view, right? So, and we have 4 agents here in the user interface. I will just make it a little bit bigger now. So basically you have 4 agents, the store manager, who is in charge of picking up the orders and figuring out what to do. Then you have the drinks agents that is in charge of going to the drink stock and just fetching drinks and preparing them for the order. And then the cooking agent who is dealing with ovens and basically will just go and pick up some stuff from the inventory and basically cook pizzas by reserving ovens and then just waiting for the pizza to be cooked. And then finally, the store manager will do the coordination across different agents until all the items for the order are ready and packaged together, that they can be sent to the delivery agent who is in charge of basically managing bikes and reserving bikes to dispatch the order to the customer, right? So it feels like there are tons of things going on. Remember that this is like a distributed agentic application. That basically means that if you look into the cluster that we're running, we can actually do that.
Yeah.
We can do this here. So just listing the pods, you will see that we actually have the agents here. So we have the delivery agent here, the cooking agent that deals with cooking the pizzas, and we have the store manager agent. And are we missing one? The store manager agent, the delivery agent, and the cooking agent.
Yeah.
There you go. So no, that's it. And the drinks agent, right? Like there should be a drink agent somewhere. But anyways, yeah. Drink stock, that's it. Yeah. So sorry, that's different name. But yeah, so that's sorry, no. I will show that in the code. The drinks agent is local to the same application, right? Now we wanted to show kind of like distribution, right? Like making sure that we have local and remote agents, and that we will use the A2A protocol to basically do those interactions when the agents are remote, because we will need to discover the agents and we will need to interact with them via like a network call. So that's happening there, but the drinks agent is co-located with the store manager agent. That's on the architecture side. But let's take a look into.
Let's order a pizza.
Exactly. Let's do that, right? So let me make this a little bit smaller so you can see it. And basically, as you can imagine, like the end user like interface is basically a chat. So I can say something like, "Can I have a pepperoni pizza and a beer. I will ask the store manager, and the store manager will pick it up.
Yeah, we should definitely have brought our own pizzas, right?
Exactly. Yeah, and basically it says like, I'm happy to help you, with the pizza order, and basically just confirming kind of like what I ordered, right? Like 1 pizza, 1 beer. Does it look good? If I say yes, that will confirm the order, basically, right? And as soon as I confirm the order, the store manager is in charge of the orchestration of all the other agents, basically defining which agent needs to be called next to do what. And in this case, because I have drinks and a pizza, it will just distribute these tasks to the drinks agent and the cooking agent, kind of like in parallel, because those two things can be done in parallel. So I will confirm this, just place the order. And basically what we will see now is that if everything goes well, you can see the drinks agent going and picking up beer, and then the cooking agent picking up the items that it needs to cook that pizza. And now the oven is blocked, and we are waiting for the oven to cook the pizza, right? Things happen fast because we don't want to keep people waiting, but you can imagine here that you will have systems that are basically doing this in an asynchronous fashion, right? Now the pizza was cooked, so a bike from the bike service is reserved, and it's actually delivering the pizza in this case. You see here that we are reporting state, and we are reporting state by sending events. And those events are also being handled by the agents. Like the agents are getting the events and being notified whenever, like the delivery arrived to the final destination, right? And whenever like all this interaction happens, the store manager is in charge of saying, okay, like the order was successful processed, and the order was like correctly delivered to the user in this case. And then we send this message of saying, hey, you got your pizza, hope you enjoyed, right? Again, tons of things are happening here, and these are agents, which basically means that each of these agents have like, let's say, an LLM behind the covers. So there is a lot of like non-deterministic behavior happening behind of each of these agents, if that makes sense.
Yeah, and all of the basically responses you have here is to some extent the reasoning going on in the different agents, right? So you can see that, okay, now the drinks agent have successfully fetched the drinks, and it got some beers in stock, and now there's like this amount available. So it's basically the reasoning that the agents are doing that is also what we try to represent here, because we really want to, and you'll see that later on, we of course want to have that reasoning in our telemetry as well, so that we actually can see this without looking at a single order in a dashboard, but can actually, derive interesting information based on the telemetry that is coming out of our agents.
Exactly, and I think that that's interesting to see also that the logic of the agents, right? Like the goal of the agent is, in this case, like the cooking agent, for example, is just to cook a pizza, and for that it needs to go and check the inventory service, see if the items are available to cook that pizza, and if they are, just fetch them, just retrieve them from the inventory, and then just go on and reserve like an oven, right? And you can see here like the summary after cooking a pizza of all the tools that the agent used to actually perform those operations, and the ingredients that it used, and all the oven that it selected to cook this pizza, right? So you can imagine a situation, and the demo didn't went that far, but like the whole intention here was to show, what happens if you have like, if you need to scale this up of having like multiple cooks fighting and waiting for ovens to be released. How do you kind of like understand what's going on, right? Like you probably cannot build a UI here that just shows you kind of like which cooking agent is doing what. Imagine like at enterprise scale, figuring out what's happening and becomes kind of like a big challenge, because there are tons of things going on behind the covers for this simple application. So going back to the slides, we wanted to quickly share a little bit about like the architecture as we explained, and then we explained kind of like what's running in the cluster. But just to go a little bit in more details, we are using MCP for connecting, the agents to the APIs that are available, right? So every agent has a way to go and interact with the inventory service or the ovens using MCP tools, and these are like remote, like client server kind of like architecture, where an MCP server will just go and call another service. We have some services written in Java. In this case, we are using LangChain4j and Quarkus to build the agents. And we have some services written in Go, like most of the inventory services are written in Go, because we wanted to basically have like a polyglot architecture, a polyglot like application that is written in different languages. We have some front end in React as well, and we are using PostgreSQL to store kind of like the state and the messages and the orders that we are processing. So we try to mix and match all these protocols to implement this business scenario. And as I told you before, right, like even if this looks simple, like on the functionality, it's a distributed application with, you can count here like 1, 2, 3, 4, 5, 6, 7, 8, probably 9 to 10 services running in a cluster, and all connected and interacting between each other, and also interacting with an external service. In this case, I think it's Anthropic. We are using Anthropic for as like an LLM, right? So we kind of like cover half of the story, right? Like, because business like companies doing this kind of stuff, they are probably running their own LLMs. But we said, okay, like let's focus this conversation on the business agent side of things, not on the infrastructure side. But we are definitely thinking about like extending the demo with like local LLMs that are running inside the cluster, which will make a lot of sense for this kind of like business sensitive information around it. So let's go into a little bit more detail of what we went through. Does that sound good, Kasper?
Yeah, let's do that. Let's do that. I think this is probably your slide, right?
Yes, yeah, this is kind of mine. So I think that like but this is at the same time, is like, this is kind of like, I think that what made us Kasper and myself like to interact with like to start collaborating, right? Like we were both interested in standard APIs and standard specifications to solve cross-cutting concerns, right? In this case, I was working for the Dapr project. Kasper was working with OpenTelemetry, and Dapr already provided some support for OpenTelemetry and observability.
Yeah,
But
and maybe also adding to this in terms of that, you are more coming from like the developer side of things, and I'm coming from the platform side of things. So we try to like basically represent the both perspectives as much as possible. Which is also interesting in some cases, the sort of the clashes and figuring out how to solve this and who's responsible. Is it the platform, or is it the developer responsibilities, right?
Yeah, and we found a lot of those kind of questions. I was like, okay, this is not working. It's like a problem of the Dapr project, problem of like we are missing some like capturing some telemetry. Is this like a problem of the frameworks that we are using to interact with LLMs, right? And I think that all those questions are kind of like part of kind of like what we did for this presentation.
Yeah.
So on the Dapr side, like quickly wanted to go over this. It's like the Dapr project does a lot of different things, and it provides a lot of APIs to abstract infrastructure. But for this presentation, we thought that like one of the main things that we are using to build this application is the workflow engine that Dapr provides. Why do we need the workflow engine for this kind of applications? Is because like all of our agents, in a way, are super stateless. So imagine that like I'm ordering a pizza, and then let's say the cooking agent crashes for some reason, right? If it crashes, how do we make sure that whenever it starts again, it continue to process the same pizza order that it was processing before, right? And I think that how do you do the orchestration across agents, right? Like if the store manager is calling the cooking agent and the drinks agent, and it's deciding when to call them and how to wait for them to finish stuff, how do we make sure that that orchestration is also durable in time, right? So if something crashes whenever you restart the application, you can continue with that orchestration from where you left off. So we are using, in this case, the durable agents with workflows, right? Like we are using long-running processes for orchestrating the agents. In this case, this is what we are showing here, is like the entire order processing is being handled by Dapr Workflows. We define how these agents needs to be executed, and we use Dapr to store the state at all times. So if something fails, we know that we can just restart the applications, and they will continue processing the order until it's delivered. And again, like as I mentioned before, there are like two angles. One is like making sure that each single agent is durable, but also making sure that the multi-agent orchestration is also durable, right? We want to know that if we are calling this agent, we will wait for it to complete. And if the agent crashes, or if the orchestrator crashes, or if something else crashes in our cluster, whenever things come up again, they can continue moving forward. And of course, like understanding how those orchestrations happen is super important. So like on the Dapr project and the company behind it, like they are providing a lot of tools to do that as well. So I encourage you to check that out. But again, like durability it's like a very long topic, but we believe that it's kind of one of the key things that you need to have for your agents.
Yes,
On the contrary, observing them, it's quite complicated as well. So we wanted to
exactly.
explore that.
And that's really where we're going next, right? Because now we've like understood a little bit of how the architecture and how the different agents and everything is connected now. But then how do we actually observe this? And we've used OpenTelemetry for this. So if you just continue, we'll just like go briefly through OpenTelemetry quickly.
Yep.
So this is just like from the CNCF survey that came out in January. It's a report about like adoption of the different projects and 49% of the respondents in the survey done by the CNCF in January from last year mentioned that they are running OpenTelemetry in production, which is awesome to see that the momentum behind the project, and an additional 26 is still evaluating it. So that's almost like 75% is either evaluating or adopting OpenTelemetry, which is a huge number. So that's awesome to see. If we take the next one. Just quickly on like the OpenTelemetry architecture side of things and how it's all connected. So basically, you need to instrument your application somewhere. So you're in this case, you are instrumenting a Go service or a Java service. You can do that in multiple different ways, and we'll come back to some of the struggles we have had with this as well, because you can do auto instrumentation with the Java agent, for example. If you want to do that, it basically just instrument that out of the box and start sending telemetry from the different frameworks, etc., that you're using. Usually that is being sent to the OpenTelemetry collector, which is sort of your collection point inside your cluster, where you're receiving telemetry, you're processing the telemetry, you can do redaction of certain attributes, etc., and then you're exporting them to somewhere, whether you're exporting them to different databases or you're sending them to an observability solution. That's really up to you. And then the last piece is around all of the different tools that you can basically monitor or observe with OpenTelemetry collector. You can observe like infrastructure, Kubernetes. I think there's like 5 different receivers for Kubernetes alone that you can like start tapping into and getting some insights into your clusters, but also, RabbitMQ, Kafka, the database. There's all kinds of different receivers for the OpenTelemetry collector that you can just put in and start collecting your telemetry. If we take the next one. So what OpenTelemetry has really done to this industry is really standardize how we are collecting telemetry. And hopefully this will be sort of the last observability agent that you'll ever install in your clusters, because you can migrate to this once and then you can just point the data to wherever, whether that is a vendor or that is an open source project like Jaeger for the traces or Prometheus for metrics. That's really up to you. That's sort of the architectural choice you have to make as a platform engineer out there, which solution you want to use. But it basically pushes the vendors to compete further down or further upstream to your basically your data collection, and it also changes what they're fighting around. It's really about providing the best possible experience with the data that you're sending them, instead of we can collect this data or we can collect this data, because that is now standardized. I think that's an awesome thing for an end user perspective, to be able to move to an open standard that just allows you to send the data to wherever you want to send it. Also multiple places if you want to, right? So if we take 100%. The next one, an easy way to get started is of course using the OpenTelemetry operator, and that was also our go-to for this particular setup.
You want me to show that?
Yeah, but we can jump into some of it, because we can maybe highlight some of the issues that we were like experiencing with this.
100%.
So I think, and you probably have some more insights into the Java specific ones, but we try to like basically use the OpenTelemetry operator to. Yeah, let's start with the instrumentation resource and just maybe explain briefly what it does. So this is the instrumentation resource that comes with the OpenTelemetry operator, and it basically it configures where to send the telemetry. So in this case, you define an exporter endpoint, which is where your collector is running, and then you can do all kinds of other things like the sampler. You can set it to different kinds of sampling modes if you want to. You can add KDIS UID attributes, and you can also configure in the environment. So it can also be used to basically as a way to centralize configuration of your OpenTelemetry configs. But right now, there's not a good way where you can only say, I want to like only use it for distributing like environment variables, because that was really what we needed in this case, because when we injected the actual Java agent, things started to crash completely.
Yeah. Yeah, and I think like that's kind of like interesting. Like that's an interesting experience. So we have like a mixed set of Go programs, like Go containers and Java containers, right? And the problem with the Java agent in this case, like that was basically kind of like our first instinct to inject into the Java application, is that the tooling, the framework, the library that it's being used to send like HTTP request or gRPC request to the collector was crashing actually with one of the libraries that the HOA protocol was using, right? So we went ahead and we reported the issue, and we actually patched the HOA library to make sure that like this clash didn't happen, because we wanted to make sure that, again, like our Java application was auto-instrumented, and that our agents could use the HOA protocol to do that. And I guess that's kind of like highlights a little bit about like what we were saying before about like the maturity of these frameworks, right? The amount of combinations that you can build with these things, the amount of different languages where you can use the HOA protocol are quite a lot, right? So by us like trying to build an example and then seeing kind of like, okay, it's crashing. Why is it crashing? And going super deep into finding it why, and then reporting it back to the project was a very, let's say, rewarding experience. Like frustrating for sure, because we expected it to work.
And we had a
But
lot of like back and forth on like what is going on here. It's like because it was like an protocol upgrade, as far as I remember. Like it tried to upgrade like to a different protocol that wasn't supported by the
and it was
receiving
crashing.
end. Yeah, and then it crashed. And yeah, it was interesting.
And when you look into those things, it's like, what the hell is going on here? Like, what, like this should be working. Like it's not work. Like it's working without the Java agent. We put the Java agent and it doesn't work anymore. And it's like, okay, then we need to figure it out. And it was kind of clear we were expecting something on the HTTP libraries, but it took us quite a while to pinpoint and then to patch. So if you look into the application code, you will see that we are building kind of like our own version of HOA. But I think that upstream it was fixed already, which is kind of like a good thing for everyone, I guess.
Yeah, and maybe continuing on sort of the
Yep.
issues and like still in line with the OpenTelemetry operator, because we
Mhm.
also had some issues around Go specifically,
Mhm.
and just before I dive into those, maybe
Yeah.
if you can show just how that works. So basically,
Yeah.
it's the same instrumentation resource, and you add these annotations that Mauricio is showing right now. So
Mhm.
basically, you define that this should be this is a Go application, and inject Go according to this instrumentation resource that you saw before. For Go specifically, there's this additional annotation that you need to add,
Mhm.
the OTel Go auto target exec, which basically points to the binary in the container. But then Go is always is an interesting programming language, and it's not really propagating the context automatically as you see in some of the other languages. So one of the things we also had to do for this application, I think Mauricio started with just using the default context and instead of the request context. And that is also an interesting thing when you're writing Go, that you really need to make sure that you're passing the context correctly in any places, so that we keep all the information around basically the context that needs to propagate between the different services.
Yep.
So propagating the request context instead of just writing context
Like
background or whatever.
exactly. Yeah. I'm just trying to
And
find that. I don't remember where it was, like context, right?
yeah, so yeah, that's a good example. So that is
Yeah.
actually the request context that you have right there that is going in.
Mhm.
And so
Yeah,
I
also
think one
here.
of the so
Mhm.
initially this was just like a background context and
Mhm.
not like preserving the actual trace context. So remember to actually take the request context, and that is what you're propagating throughout your whatever function calls or whatever you're doing in your applications.
Yeah.
The other thing around Go is it's eBPF instrumentation. So you will have a sidecar. If we
Mhm.
jump back to the yes, if you scroll, yeah, there we have it. You're just there. If you just scroll a little bit up, yeah, there it is. So basically, as you can see, it's the OpenTelemetry auto instrumentation. It's a eBPF sidecar that runs next to applications. So this is also a little bit different from Java, for example, which is
Mhm.
basically it's tampering a little bit with the Java tool options and fetches a Java
Jar.
instrumentation
Yep.
jar, and then it basically copies that. It does that in the init container and copies over to the actual main container, and then it executes that. So depending on the language, you will also see some different ways of setting this up. And what we then ended up doing for the Java one was we still used the OpenTelemetry operator to basically distribute this configuration, because that was actually quite nice to be able to still distribute the configuration around, the endpoint of the collector and all of these things. But you need to disable the actual injection of the Java agent.
Of the Java agent, right? Yeah.
Exactly. So it was an interesting experience, trying to get all of this to work and having basically the context propagate correctly. Should we jump back to the slides quickly?
We can do that, yeah.
Yeah, so that's basically that. And let's continue on with the next one. So why is this hard to observe? Yeah, you can just click through. So we have all 5. Yeah. So basically, traditional tracing was built on this request response kind of parent-child relationship, and that's just a little bit different when we're moving into an asynchronous world. And as mentioned before, the context propagation often breaks either between the different tools that you're using, as we were just alluding to. It could not propagate, or maybe it's because you're using Go and you forgot to add the context, as we were just showing. Agent decisions create these non-deterministic workflows. So that's also a new aspect to what we're coming from, that where we have a lot of determinism. Now we are moving into the world where things are not always as we expect them to be, right? And then the execution spans many different systems now. So it's services, it's LLM, or it's maybe an agent that calls an LLM somewhere on a cloud, or it's running on a GPU somewhere. There's a lot of new systems involved, and actually some of the key context is usually in our case it lives in what the LLM is actually doing on the Anthropic side here. So we need to observe different things than we're used to, right? We need to understand the reasoning. Maybe we also, of course, want to understand the token usage and stuff like that.
Yeah, and I think that with all new protocols, right? We saw actually changes for the A2A protocol, from the MCP protocol, and even from skills. We wanted to create one agent that basically use skills to interact with an API, right? Because we wanted to see how different it is from the MCP side of things and from the skill side of things. And then we started finding out all these little details about how that works, that I think that it made it really interesting to start then thinking, okay, so how do you make skills resilient or secure or observable, right? And we focused on observability, and we found a bunch of interesting stuff there as well. Maybe I can go and show a little bit of that.
Yeah, sure.
Yeah. So
we're freestyling.
Yeah. No, I think that just showing people a little bit about the agentic side of things. I think that I wanted to show, for example, here, I think that this is the store. So for people that hasn't built any agent, agents are usually basically a system prompt that basically says what the goal of the agent is. It allows you also to get user messages. Basically, the agent has a goal, but the user can ask the agent questions or to perform tasks. So that's kind of the user message. And in this case, I'm using I'm showing here the LangChain4j way of orchestrating things. In this case, we have a sequence agent that basically has a goal of processing pizza orders. And it has a bunch of sub agents. You can create a topology of agents that are going to perform different actions. You see here that this is kind of where the orchestration, the workflow side of things kind of materialize, but kind of expressed in a way that you are defining agents and their relationships. How do they call each other? So I wanted to show a little bit about that. So that's kind of how you define agents. We can see, for example, the drinks agent that I told you before, that it's co-located with this application. It's running in the same container. And that also brings those architectural questions. It's do you want to run all your agents in the same container? Then if the container dies, all your agents die. Do you want to build a distributed application where you have each agent is its own container? Well, you will need to be able to answer some of those questions to architect these systems for scale, right? So here we are defining kind of an agent, and that's the goal of the agent. You are in charge of fetching the drinks, getting all the drinks from the drink stock, And then if you don't, if you don't call that, if you cannot get the item from the stock, well, you cannot, put that drink into the order. Then, of course, you have a way to register this agent, let's say in a registry. So whenever like the orchestrator wants to get some drinks, it can find this agent, right? Then you have a way to connect agents to tools, in this case using the MCP protocol. And when you use this MCP toolbox, basically what you are saying is, I have a server in this URL or in this place that it's running. You need to connect to it and then fetch all the available tools, right? So it's basically saying that this agent will use some of the tools in this MCP server, in this case called Pizza MCP, to fetch whatever tools are related to fetching drinks, basically from the inventory, right? Which is very, very, let's say, very broad, right? Like it will figure it out when it's running, when it connects to that MCP server. And then you can use the A2A protocol to connect to remote agents. So in this case, I do not have the definition of what this agent does, but I have like something that's called the agent card in a way, which is basically the definition. It's like an interface that says, I'm this agent, I do this. In this case, you're in the client side, or like this is the orchestrator, so it has like a URL that can be used as a discovery mechanism, right? You can see this is like a kind of like a Kubernetes service name of where the agent is, and the orchestrator can go there, fetch all the capabilities of this agent, and then use this agent as part of the orchestration, right? You can see the delivery agent is a remote agent, and the cooking agent is also a remote agent, using the A2A protocol. So whenever the store manager needs to cook a pizza, it will call the cooking agent. Whenever it needs to deliver a pizza order, it will call the delivery agent using the A2A protocol.
Should we quickly jump into the skills and then maybe jump into
Yes.
like actually seeing
Viewing.
some of
Yes.
the
Let's
data
do
coming
that.
out of all of this?
Let's do that. I just need to figure out where the skills were, because that's kind of like an important part.
While you figure this out, I just want to let people know, if you have questions, you can ask on the Q&A, and then we'll get back to you after. We can send you the answers, etc. If you have a few questions, because I know we're almost short on time, and
Yes.
this presentation is great. So any questions that you have, feel free to ask them, or in the chat as well, and we'll get back to you after.
Perfect. Yeah, we will just go quickly over the skills. I think that the agent service basically is using skills to interact. Yeah, so here you can see with the bikes. So the delivery service has like a bike tool that is basically using a skill definition that defines how to interact with the bike services. We can see here, let me see if I can find it here on code, Salaboy. Let me quickly open this. We have like a directory that's called skills. And we have a skills for bikes. And this skills is pretty simple. It basically is like a skill MD file. Let me see if I have it here so I can quickly show it. And then we will just jump and say, yeah. So you have a skill that basically says, if you want to use bikes, this skill will allow you to know how to list, get bikes, or reserve bikes, right? And how does this skill works is by just saying, hey, whenever you want to list all the available bikes, you have a script that it's called listbikes.sh that you can call, and this script is here, right? And if you go to like skills.sh to download skills, you will see a lot of things that looks like this, that basically are calling services or using Python scripts to just do stuff.
Yeah, and maybe just a quick comment on this one is also,
yes.
you probably notice an interesting that we are passing like the trace context into the bash script as well to sort of get some insights on the skill execution as well. So this is just like a dirty hack of trying to get this to work as well, because we wanted to have this part of the full trace as well, that it actually executed the get bike script.
Exactly. So the idea here is that we modify like the base skill, let's say, to make sure that we can do like trace propagation in this case, because if not, like we were just losing track of what was going on. Like the agent calling this service like was completely broken into different traces. And
Let's
with that, I think that we can
let's
go
jump to the application, go to Dasiro, and then we can show some of the traces. I think we'll just skip the remaining part of the slides and just show a few things. Because as you can see right here, right, that's in this case, there's 219 spans in a pizza order. it's there's a lot of stuff going on here.
Mhm.
One of the interesting things around like starting to instrument everything is that you, in many cases, you probably also get, as you can see, there's a lot of spans here that might not be very attractive for you as an end user. So that is also a thing around maturity in this space, is that who is the project actually designing the spans for? So that is an interesting aspect for you to look into as well when you are evaluating different projects. But
Mhm.
if you just like find some of the stuff around the completion steps, maybe we can show a few of
This
those.
one. Yeah, definitely. So this
So
is the call to the LLM, right?
yes, exactly. And the GenAI.completion in this case is basically the agent reasoning going on and captured as a span attribute. And all of what you see here, the gen_AI is the GenAI semantic conventions defined in the OpenTelemetry project. And it's pretty cool that you can get all of this information, so you can understand what was the actual prompt that went into the LLM in this case, and what
Mhm.
was the output or what was the completion. And you also get, if you scroll down a little bit, so you get the model, you get all the tokens that are being used. So all of this insights is of course something that you can take and basically calculate things around your basic usage of Anthropic or whatever you want to do with it. But maybe if we do you have yeah.
One thing to mention here, I think it's super important, is that sometimes like understanding what you're sending to the LLM is really difficult because of skills, for example, because of extra context that you have in your session, right? So being able to see what was actually sent to the LLM will give you kind of like a clear context of, okay, I got this response because this is kind of like all the things that the LLM saw basically in the request.
Yeah. Do you have
Yep.
our agent zero interaction where we can basically
Yes.
summarize all the Gen AI completion? Because it's right now
Yes.
it's I think
Let me
the
see here.
industry is in general is trying to figure out how do you actually then reason about all of these Gen AI completion steps, because that's really sort of the
Mm.
interesting aspects, right? To basically pull out all of the reasoning and try to put them in chronological order and get
Yeah.
that overview. I think it's one
Let
of
me
the
see.
other ones that you have.
Let me see. Yeah.
Yeah,
It's
if you
this
scroll down
one.
to the scroll to
Yeah.
the bottom, probably no, not that
Let me
one.
see here. Not this one. So this is the
No.
cost one, right? Like, so basically we were just trying to figure out kind of what the cost is. Yeah, it's I need to figure that out, but like let me see here. So
Yep.
just to summarize that, right? So we were sending kind of like a lot of requests and getting a lot of orders. So we started thinking about like, okay, how can we actually use this information to understand what was going on with the store during the day, right? And you can see like to like simple questions like how many pizza orders did we receive today, right? We can just by just evaluating the traces and all the telemetry that we get from the application, we can actually get some pretty kind of like crisp answers of, okay, yeah, today we got like 6 pizza orders, right? And we
Yeah.
started like analyzing these from 8 a.m. to now, right? How many times this thing happened and got to completion. Basically, that's something that it's important. I need to figure out like the summarization one. Where is that? Do you have the link maybe? Do you want to
Uh,
share it? Do you have it?
no, I don't. Give me 2 seconds. I think Julia is probably also want us to wrap up soon.
No, no,
Yes.
but I think we still have 4 minutes. I was just
uh,
gonna mention if you want to tell people what Agent Zero is, because we brought
Yeah.
up and it's on our platform. Do you want to
Mhm.
tell them a little bit about Agent Zero? I think that would be cool.
Yeah, we can do that. So basically, Agent Zero is our agentic AI solution at Dash Zero. You can do all kinds of interesting things. Right now, we have 6 agents that are part of the solution. So we have like a thread weaver. It's called. It's like a trace analyst agent that you can. So if you go into a trace, you can basically
Mhm.
ask it to analyze the trace. You can ask a question as you saw before around like business context, etc. I'd like to extract interesting information. You can also use it to basically ask it to generate dashboards and help you with that, these aspects, but also basically just asking questions about your systems. Is everything okay? Is there anything, is it going as it's supposed to? What are the duration? What is Yeah, but there's a lot of things you can use your imagination and start like asking questions about your systems is quite interesting, like new experience in this world of AI, right? That we have all of this data and now it's just available and we can just ask questions in a natural language, which is pretty cool.
And I think that like this shows kind of like one of the use cases that we wanted to show here is like these agents are not deterministic. So we asked to compare two orders, and basically you can see that like two orders that were pretty similar, they have different numbers of spans. That basically means that, you know, there were like different decision points that the agent made differently for each of the orders. And you can actually have like a clear and comprehensive comparison here between these two orders and the behavior, right? And it's basically saying, yeah, you know, this is like, it's expected behavior for agentic architecture, so we need to get used to it, right? And if you want to understand what's happening in this application, we need to actually be able to ask questions about like what was the difference in the business outcome from these operations to understand kind of what the agents actually perform there for each order.
Exactly.
Yeah.
And that is an interesting point, right? Because how do we, because now we just get text, how do we evaluate whether that text is actually how confident was it in basically what it was doing? So we also need to like talk about like evaluations of the actual output that an agent produces, and so that. But I guess that's a topic for a different webinar at some point to go into.
Part number 2, exactly. Yeah, no, it was really good. It was awesome because we had time to go over a lot more details than what you presented at KubeCon. At KubeCon, you know, you had what, 30 minutes or even a little less than that. And today you were very thorough, showed us a lot of from the demo, and it was great. I had a few questions, but actually you answered them throughout the presentation. I don't see any questions from the audience, so I think we can wrap up. And definitely we should schedule a second one, because I think this is a topic that everyone wants to know more. You know, agentic observability, also the workflows with Dapr. So yeah, keep an eye out. We're gonna be doing more of these webinars with people from the community around observability, around OpenTelemetry. And yeah, again, thank you, Andrew, and everyone that watched us. I don't know if you two want to share something before we close.
No, just that, the same thing. I think that keep an eye on, because we will do much more of this. There's so much to cover that we just need to keep doing this.
Yeah, I think Mauricio just published a blog post yesterday about some of the things in specifically for Java, right? So that's a good place to start to read up on some of this as well.
Yeah, cool. Thank you so much, everyone. Hope you have a great day.
Thank you. Bye.
Thank you. Bye, guys.